Hello and welcome to the Reliability Center's iPresentation series. This series of videos is designed to help you improve reliability at your facility. Today's topic, using Proact Logic Tree knowledge management templates in Logic Tree development. We're including a hands-on demonstration, so let's get started. I'm Victor May, your host. Let's begin with the definition. Root cause analysis is the establishing of logically complete, evidence-based, tightly coupled chains of factors from the least acceptable consequence to the deepest significant underlying causes. I know that's a mouthful, but what this means is that when you're conducting a root cause analysis, you want to not only identify the physical factors that contributed to the failure mode as responsible for the incident that you're investigating, but you also have to go deeper and look at the human and latent system and organizational factors that contributed together in the actual occurrence of the event and failure mode that we're investigating. The Reliability Center has developed the Proact root cause analysis approach. This 5-step process starts with the preserve step, getting the information necessary to successfully complete your analysis. This is the most important step and where you will solve the problem. Then there's order. Ordering is about picking the right team member dynamics, roles and responsibilities, and other topics. The third step is analyzing. In analyze, we actually work in conjunction with Preserve to build a logic tree which you use as a guide and guides you to all the possibilities that you should be looking at in performing the root cause analysis. And this is where we're going to concentrate with our new knowledge management templates today. Then there's communicate. You have to communicate your findings and recommendations back to management and ask for resources to implement the recommendations that come out of your root cause analysis. And finally, you have to include tracking. That is, measuring the results, the metrics that you'll use to confirm the effectiveness of your recommendations once they're implemented and in place. The Reliability Center has a unique software, Proac Suite, that includes 2 major modules. The Proac software module for advanced root cause analysis and the LEAP software for opportunity analysis and basic failure modes and effects analysis. We're going to concentrate on the former today, as this is where we'll be working with the new templates. The Proact Logic Tree knowledge management templates are the next step forward in root cause analysis software. The templates, we have to remember, the process is not designed to replace the thought process that you use while conducting the root cause analysis. It's recommended that the team first exhaust the possibilities from within their team members before taking a look at the templates and using the past experience provided by the case histories incorporated into those templates. In this way, you use the templates as a supplement to the team's own experience, enhancing the learning process and internalizing the learnings from the root cause analysis. It is a quick method of leveraging the knowledge base to help users build a more comprehensive logic tree because it provides more possibilities. Again, do not narrow yourself just to using the templates. How does the software work? Well, it uses the previous suggestion arrow, which is right here, which is on the toolbar underneath each hypothesis box in the logic tree. So, for example, you see the words heat exchanger issue. The software can automatically search on just the word or the entire phrase. And the software will search all published templates and analyses that you have already published within your desktop copy or your network version of the software. If it finds related information in any of those templates or analysis, it will populate a drop-down list. So let's see how that works. On to the software. Let's pretend that we're part of a root cause analysis team that was put together because of a significant event. And I've already provided the top box here, which includes the event and the failure mode. The event is the reason why we care. And as you can see, we care because we have reduced output of production line 2. The failure mode, recurring reactor cooling water supply pump failures. When we build a logic tree, we should start from the broad and become more specific. So the team worked hard. In the next level, fairly broad, they said, how can the recurring reactor cooling water supply pump failures be occurring? The answer is it could either be mechanical failure or electrical failure. Pretty straightforward. Then they took a look at mechanical failure, and they were able to come up with a few hypotheses. Bearing failure, shaft failure, coupling failure, and seal failure. Now the team, as one of their preserved actions, was taking a look at the work order history and interviewing operators and mechanics to determine what types of mechanical failures had actually occurred. And they had determined that bearing failures and shaft failures and seal failures were not occurring. So you see, I've marked these as untrue, and we're following coupling failures because they did determine that they'd had a number of coupling failures. Since the team knew this was the case, and they were getting data also from the work order system, they looked at how can we have coupling failures, and came up with several answers. Bolt failure, and these are fairly simple couplings here. Gasket failure, and distortion failure of the flanges. Now they were also collecting material from failed parts, and they had just had a pump failure, so they had some of these bolts, and they had a metallurgist on the team. And they had broken bolts, and they determined that these bolts were failing due to fatigue. Now, by the way, just to quickly show you, it's very important when you're doing an analysis that you don't mark things true or untrue until you have a verification method. And we use a 0 to 5 scale, with 0 being untrue and 5 being true. And I'm creating this quickly, so I may not mark every box here. But you would use a verification method. And this verification method is answered like so. Visual inspection by metallurgist, followed by metallurgical analysis. Okay, and that's our method. And then we can say our outcome was the metallurgist confirmed bolts were failing by high cycle fatigue. Okay. And when I get the report later, I can add a file link right here. Now, fatigue is a physical root. Now, at this point, though, the team was a little bit stymied. Okay, how could these bolts have failed from fatigue? And if I can't answer the term how can once I have a physical root, I can say why. Why did fatigue failure occur? Now, when you run out of ideas and you've exhausted the possibilities, now I can look at the templates, and there's two ways to do that, and we'll use the first one now. The view feature in the top bar and templates. You get the notice of intellectual property, which you check off, and then a list of topics shows. There's topics and showing the templates by individual name. So, for example, here's bolt fatigue, and here's the subcategories under each of these, or I can show the template names, and then if I wish, I can look at each template for bolt failures, and you see this one is associated with stress corrosion cracking. This one is associated with fatigue. Okay, and as the team looks at the subcategories, say, well, the metallurgist said, well, these bolts failed by fatigue, and the fatigue cracks all seem to be initiating at the thread root. So you simply click, and a template appears, and here is the box that I've highlighted. If I like this box, then I can simply click on it. Now notice with the template, I can either begin a new Proact analysis using the selected template, or since I'm already building my case history, I'm going to copy the selected node and all of its children nodes, in other words, the boxes below it, to the analysis. Okay? So I copy, I come here, and I paste. The template information has been added. Okay? And again, I have the further hypotheses. I'm going to know this is true. It's going to be a physical root. And I'm going to keep going. Alright? Now again, my logic tree tells a story. Right? I have fatigue cracks initiating at the thread roots, which resulted in fatigue damage, which led to bolt failure, which led to the coupling failure, which resulted in mechanical failure of the cooling water supply pump. That's one way. Now we use the electrical side to demonstrate the other way. Now similarly, when the team looked at electrical problems, now they weren't quite as strong electrically, but they knew a few things that had happened in the past, including motor failure. And again, we want to start broad and become more specific as we work our way down the tree. Power supply could fail, and they knew that they could have control failures around the instrumentation. So we quickly add those using the hypothesis list feature. Now though, the team was kind of stymied because, as I said, they were a little bit weak in the electrical. Now at this point, you should have a discussion about whether to get an electrical expert and add them to your team, at least temporarily, or not. And you can go ahead and see what's in the templates. And this time we'll use the previous suggestion arrow. First click on the previous suggestion arrow. You see the icon flashing here. I can select either the phrase or the individual word. Let's just use the phrase. And you see that a large number of children have appeared for me to select from. So the team takes a look at these items and they select a few. Well, they select motor overheating. So they knew that could happen. And they select overload and winding failure. Now I click up on the previous selection arrow and my children appear. And again, if I want to, I can repeat this. Motor overheating. You see 3 children come up, and we'll say that, well, we think block cooling channels could be reasonable, excessive starts and stops, but the low bus voltage, we're not very confident on that at all, so we decide not to add that. And you see we have now added 2 more children. And again, we're building the tree fairly quickly. Just to give you a feel, you see the electrical side and the mechanical side building right out. Okay? Now let's go back to our presentation. You cannot do what you cannot imagine. Now that you've seen the Proact Logic Tree Knowledge Management Templates in action with the Proac Suite software, can you imagine conducting your analyses with the support of these technologies? If so, and you want to learn more, please come to our website at www.reliability.com. We look forward to hearing from you.